Hey, very good morning, students. Let us look into the next most important topics in Unit 3. Unit 3 is a combination logic circuit. What are the important questions you get is very first pattern I could observe is code conversion. So one question you will get from code conversion, converting BCD to XS3 or BCD to gray or binary to BCD. Can you see this question is BCD to XS3. Next question I've seen is code conversion is 4-bit binary to BCD. And these are the questions you can expect from code conversion. So one takeaway is code conversion. Second one is, can you see one common thing? They have asked about full adders. Design a full adder using two half adder. Can you see design a full adder using half adder? It means this question is repeated twice. If you want to design a full adder using half adder, you have to use two half adder and one OR gate. This is directly given in the question. Here they have just said design a full adder using half adder. It means indirectly you have to use two half adder and one OR gate to design a full adder. So again, this is a repeat. Can you see the third 2020-24 design a full adder with truth table? It means there is one question out of 6 papers, 3 papers have full adder question. So designing a full adder is important. And next takeaway is about demultiplexer and multiplexer. There is one question, 1:4 demultiplexer 2023 main. 2023 supply they asked 4:1 multiplexer. Can you see again the same question is repeated. There is one more question where they have asked about draw and explain 4 to 1 line multiplexer. Draw and explain 4 to 1 line multiplexer. Draw 4:1 multiplexer. It means the question is repeated twice. 2023 supply and 2024 main, the same question is asked, but the pattern of question is different. Explain its operation with help of truth table. Here he said design, draw and explain 4:1 multiplexer. So next takeaway for us is multiplexers and demultiplexers are important. You need to know how to design a multiplexer. You need to know how to design a demultiplexer. At least 4:1 or 1:4 demux. Next, magnitude comparator is one more question we could see. And the last pattern is very important pattern here, where they have asked to design a 4:16 decoder using 3:8 decoders. So this is also repeated in one more place. Design a 4:16 decoder using 2:8 2:4 decoders. So a decoder question is also important. From all these questions, what is important takeaway is full adder. Can you see this is part A? I will finish part A and then get into the conclusion. Part A, design a half adder circuit. Second, part A, one more question, design a full adder circuit. What is combinational circuit? What is multiplexer? Write its applications. Draw a full subtractor question. So from all this part A and part B, what is that repeated pattern we could see is definitely you will get a question from half adder or full adder, half subtractor or full subtractor. One question is guaranteed. If it is full adder, definitely you will get how to design a full adder using half adders. So this is a kind of trend that I could see from the questions. Next, code converter. It can be any code converter. Convert BCD to XS3 or binary to BCD or BCD to gray. Any code conversion. One question from code conversion. Next, don't miss multiplexers and demultiplexers. 1:4, many is to 1, 4:1 or 1:4 multiplexers. Then magnitude comparator, 2-bit comparator or 4-bit comparator. In this question they have asked 4-bit comparator, magnitude comparator. Finally, designing a decoder. Since you have got all this question, this time I somehow expect a question from encoder. That is why I've written encoder is also important. So designing a decoder or encoder. Can you see this question is again they have repeated twice. Design a 4:16 decoder using 3:8 encoders. So this is a repeated question. I have seen this question even in other paper where I just want to show that question. Design a decoder. Can you see? Realize 4:16 decoder using 2:4 decoders. It means it has come as a 5-mark question in 7th question of part B. So this is one type of question that you may expect. This is a very important question also. So make sure you understand how to design a decoder, 4:16 decoder using 3 by 8 or 2 by 4 decoders. Same pattern. The pattern will be very easy, very similar. So these are the things you shouldn't miss when you prepare Unit 3. So Unit 3, adders, subtractors, half and full, then full adders, designing a full adder to using two half adders, code converters, mux and demux, magnitude comparators, and designing a decoder using a bigger decoder using smaller decoders. And finally, don't miss encoder. Somehow I feel you may get priority encoder or encoder question, though which is not asked in any of the question papers, but encoder is important. You may expect an encoder question. So this is my takeaway for you. So learn these topics from Unit 3. Thank you.